Hey, what is up, the peoples? So check this out. We've got this Westfalia lamp fixture here. This is a fluorescent light fixture from a Volkswagen camper van, I believe. And it's not working. And this is a rather simple device, except it doesn't use like a incandescent bulb or something. It has a fluorescent tube, as you can kind of see there as I put it in at an angle. And some of you may already be thinking like, well, just replace the tube. You should be good, right? Well, I don't believe so. But yeah, probably not exactly. So let's go ahead and take this cover off. And if I kind of move this multimeter here into the shot, and I show you this here real quick, we see that on these alligator clips, I have not resistance, but I got about 13 volts there. So I've got a power supply right there supplying power. And if I hook those up to these two terminals in the back here. Let's go ahead and zoom in on that. All right, we can see we've got a couple little markings right there. It's a little hard to see because there's a little bit of residue on there. But anyways, there's a negative mark right there. So this terminal lug here is negative, and this is positive. And I mean, I believe it. I'm pretty sure that's what those are signifying there, because it makes no sense for the tube to be the ones that are marked here. This is going to be the inverter module here. So yeah, let's go ahead and hook up negative to the small terminal there, and we'll hook up positive to the big terminal. And if we flip the switch, we can see that we get nothing. So it doesn't appear to be working at all. Now, I'm saying that I don't believe it is the lamp, because also if we remove it from its fixture, and it's got these 4 screws on this 4-position connector, then we could just kind of slide it out and pull it out. If we get the multimeter here back in the shot, and at the moment I've resorted to using my very old Radio Shack multimeter, because my other one's still no good, although I don't know if it will be before this video or after this video. There should be something going on with that, but we'll see when the time comes to that. But anyways, if I check the filaments here, because there's going to be a filament on this side and there's going to be a filament on that side of the tube, and then they're joined up here at the top, so that's like where all the electrons and stuff are going to kind of flow through to light up the tube. If I check the resistance between the filaments, on filament on this side here on the left, we have about 12 ohms or so. And then we check the other side, yeah, we have about 12 ohms as well. So the two filaments appear to be okay, and if the filaments are okay on the lamp, it's pretty indicative that there's nothing wrong with this lamp. So anyways, let's focus back on this portion here. Now, unfortunately, because the switch is mounted on the top here, there's not going to be any way to pull this board out. So first thing we're going to need to do is we are going to need to remove that switch, and I'm going to do that by using the solder sucker. The solder vacuum is hot and ready, so I'm going to actually start by putting in a bit of flux on those two terminals there, just to facilitate the flow of the old solder. And I've already cleaned this out, so I shouldn't have any issues. And let's go ahead and heat that up there and give it a suck. Good job. All right, cool. I'm going to suck up all this extra flux that's kind of like floating around there. But that looks pretty good, and it's detached from the hole. So nice, clean job by this solder sucker. Okay, cool. Let's now, well, first of all, I want to make sure that it's like detached, and as we can see, yeah, that's detached, and that one is free to move around. So now it looks like we just have to maybe pry the board just sort of gently here. It's got these little tabs, one on there, right up there. These are actually, these have cutouts, so it should just sort of like slide over those. But maybe I'll need to push on the, I'm going to push on the connector on this side here while I'm prying up on the plastic, and maybe that'll help it. Yeah, there it goes. So it came over that tab there. Okay, and it can't come over that tab there. So now it should just come out, I believe. Yeah, there it is. Yay. Wow, that's a big, oh no. That does not look good right there. I was actually sort of more hoping that it'd be like a bad transistor or something, but that transformer is definitely not looking so great. I don't know what's going on with that there just yet. Wow, there's actually a lot more in here than I thought. I didn't actually expect to see any ICs at all. I thought it was all actually just going to be sort of like self-excited by the transformer. Although, if you look at the other side, when there's only two contacts, that doesn't make sense. If we were to have the transformer kind of like self-excite the circuit, then there'd be like a few more terminals there to turn the transistor on and off to oscillate. But it does not have that, so yeah, it's definitely looks like it's controlled by that. And that there is a, it's gonna, I can barely kind of see it here. I can't tell what the last number is, but oh yeah, it appears to be an LM339, so that's gonna be like a quad comparator. And that up there is a NE555. Oh yeah, it's a 555 timer. So I'm guessing they're using that one to produce the pulses, and then I'm not sure why they would have to have a quad comparator for that. Maybe monitoring current or something? I don't know. But anyways, yeah, that's all that's in there. So we got an inductor there. We have 3 electrolytic caps. We have a couple of, these are going to be like film capacitors, like wound film. And then we've got, this is going to be Buzz 71. That's going to be like a MOSFET. And that's probably also going to be a MOSFET. I can barely see the numbers on there. It's P19NB20. Actually, that might be a MOSFET. So, that does not look good. I don't like the way that looks there. We may just have to remove that transformer also. Actually, now that I'm paying a little more attention to it, it might be, that might just be some blue ink on the coils there. It doesn't look burnt. I thought it was burnt at first. I'm going to remove the transformer. I'll check the resistance of the coils like outside of circuit and see what that looks like. So again, going to put some flux on the 4 terminals of this transformer. And this appears to be old enough that it's not using lead-free solder, so it's actually able to melt fairly readily. And everything comes off right away. Cool. All right. I love this thing. This is like one of my favorite tools that I have, even though it's like a pretty ancient tool by like current standards, but it does such a great job. All right. So now this transformer should just come out, and this terminal on this side doesn't appear to be released yet. So there it goes. All right, so that's the bottom of the transformer. All these terminals look pretty good. So I don't think the transformer might be the issue, but we're going to go ahead and check resistance on that. So this side is going to be the primary. That's the one that's having its power switch there. We're getting about 0.4 ohms on that, although I think the contact resistance on these is kind of, yeah, so it looks like it's about 0.1 ohms that it's measuring. And on this side, we are measuring about 7 ohms. And once again, this is DC resistance. It's not going to be like impedance or anything. But that means that there is continuity there. And I'm actually going to zoom in on that just so you guys can see that it's not, it doesn't appear to be burned. It appears like it's just some sort of ink there. All right, so that's zoomed in right there with the microscope. And as you can see, yeah, it definitely doesn't appear to be burnt because it's not very consistent like lengthwise with the wires there. It just kind of appears to be like sort of like it's been something kind of like brushed on. But yeah, so it looks like it might be some sort of a ink or something like that. I mean, if we look up here, we see all this sort of like white crusty stuff there. I don't think that appears to just be some sort of residue. That also doesn't appear to be like corrosion or anything because it's not just on those coils there. If we kind of like flip this over, we see there's also some like crusty stuff kind of right there on the plastic. And yeah, this all these appear to be pretty good. So I'm not leaning towards this transformer being bad. Looking at the main board here, and let's see. So we have, that's the positive. Looks appears here, goes to the switch. The switch goes to that contact there. It goes, that's kind of funny. It's got that sort of little spiral there. It goes to a via. On the opposite side comes out in spiral, so that looks like it might be used, being used as like an inductor. And then it's got another inductor up here at the top. So not entirely sure why they would have needed to do that if they had an inductor there already on the input. So it goes to that inductor. Inductor comes out to here, and that goes to the positive on the, or actually one of the terminals of the transformer. So basically what they're doing is they're just switching the other side to ground, and it's just, yeah, this side's positive all the time, and this side keeps getting switched to ground, and that's how it produces an alternating magnetic field there that's going to generate the high voltage on the opposite side. And there's not much going on there. It's just one terminal looks like it goes to that pin right there, maybe, or maybe it goes to that one, because you just kind of like see it going there, but then you can't really tell where it goes. Looks like they might be doing some sort of voltage monitoring with this pin right there or something, and it goes to a resistor. Yeah, that high voltage pin there appears to go back to here, so it looks like, yeah, they're I'm guessing, yeah, they're going to be using this comparator here to like do some sort of sensing to see if the thing is working. So there's the 555, and I mean, nothing looks bad here. This all looks pretty good. None of these resistors look burnt or like the solder is cracked or anything, so I don't have a reason to believe that any of these passive components are the issue. Let's see what we can find with these two transistors or MOSFETs. The pins on those all look pretty good, so it doesn't look like it's a contact issue. Nothing looks like a bad solder joint there, so that looks pretty good. And nothing else on the board looks bad. I wonder what that is. That's negative, negative, positive, positive right there. Doesn't really seem to go to anything, so who knows what that is. Wrench. And this is all Lick Technic, I guess. That must be a part number there. Yeah, nothing else here looks bad. That contact looks a little wonky, but it looks like it is making contact. So, all right. Let's check those MOSFETs. Before we do that, though, how about we actually check the 555 and see if it's actually outputting any pulse when we have power applied to it. Now, I don't have the power on just yet, but I've got the scope hooked up here, and I'm going to probe pin 3, which is the output of the timer here, so that'd be pin 1, 2, and 3 right there. So I'm going to, well, first of all, I need to bring up the scope on the view there. There we go. It's right in the corner. And I'm going to turn power on. And let's see what we're getting at that pin. So, touching it. Oh. We're not getting anything. That's interesting. Okay. Oh. I'm such a... There's no switch. Oh, dumb. Some of you are probably like yelling at the screen like, hey, you don't have any power going to it. All right, let me just install some sort of jumper in between those 2 points. Right there, I have it at 5 volts per division, and I have it at 20 microseconds. So you can see we've got pulsing there. So that should be going to this side of the resistor, and it is still there. And then that goes over to that via, and if we flip this over, comes out here, goes to this transistor or MOSFET. So, yeah, I would say this MOSFET is probably not switching. Let's see what we're getting. I mean, at this point, we're not really going to have any. Yeah, we wouldn't have anything there. One sort of interesting thing here is that the MOSFET that switches the transformer, the source for it isn't actually connected directly to the ground. The ground actually goes to the Buzz 71A MOSFET that's on this side, and the drain from that, or not the drain, but the source from that is the one that's actually connected to the source of the switching MOSFET, which is kind of weird because this is also an N-channel MOSFET, so I would have thought that they would have put the source connected to ground and then the drain connected to the source on this one, but that's not the case, so not entirely sure why that is. But if we check a voltage between positive and what would be the source here on this MOSFET, we should expect to see 12 volts if this is on. And I haven't checked it myself yet, so I'm not entirely sure, but yeah, there's voltage present there. So it appears that this one is allowing some voltage to come over to this side. And if this was switching, then we would expect to see something happening with that lamp. That doesn't appear to be the case. Well, 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 check this out. So I had kind of dismissed that sort of wonky looking connection there, or slightly broken looking, to maybe not be a problem. But if we actually zoom in here, look at that. That looks pretty broken to me. So chances are maybe like some arcing or whatever could have caused it to just fully not make contact anymore. So maybe there's actually nothing wrong with the circuitry after all. What I'll do is I'll flux all these points, and then I will reflow the solder on them, and we'll try it again and see if it works. I mean, that's the only obvious issue that I can tell at the moment. Before I reflow the solder on that one, though, I'm just gonna actually remove the old stuff just to make sure there's no like garbage that's kind of accumulated inside of that. So go ahead and suck that out, and looks like it came out the other side. I'm just gonna make sure I heat up that pin all the way, get everything out, and that looks pretty good, I think. All right, so now all 4 of those should definitely have really good continuity going all the way across. All right, let's go ahead and solder the transformer back on. So it went like that. And there we go. I'm just going to kind of put some pressure on the transformer from the opposite side and heat these joints back up just to make sure that it's seated all the way on the board. Okay. There we go. Transformer back on. Okay, I've got my jumper reinstalled. All right, we're going to tighten down these terminals again. And I mean, I'm not like cranking them all the way down. I'm just making sure that they're somewhat snug and making contact with the terminals on the end of the lamp there. And let's go ahead and hook power back up. So positive was the wide one. Negative was the not wide one. And so basically this would be like the switch is on at the moment. And now let's zoom out so we can get the more of the lamp in the shot here. Okay, here we go. I'm hitting the power switch on the power supply. Let's see if it lights. And oh, there it goes. Yeah, it was a bad contact there on that terminal. Well, that's interesting. I totally missed. Well, I mean, you can't even see it from the outside, so it took looking at it up like really up close to be able to see that that was the actual issue. So yeah, nothing wrong with the electronics at all. That was actually a lot simpler than I had originally thought it would be. I'm gonna hit it, turn the switch off over here so we can turn that off. Wow, that's cool. So I'm gonna go ahead and reassemble everything then. All right, let's go ahead and power back in. Negative, positive. And the switch is off here. I'm going to turn the power supply on, but because the switch is off, it shouldn't do anything. Let's zoom out a little bit more so we can get the whole thing in the shot. There we go. And give it a second. And now it doesn't work anymore. All right, what gives? I think everything is tight. Wow, that's interesting. You're gonna be kidding me, but is this switch actually bad? Let's see if we're getting any voltage on the opposite side of that switch. What if it wasn't even that? What if it was just a switch that's not letting power come through. Oh, won't that be something? All right, so negative here. Obviously, this should have 12 volts, and it does. And I think I just hit the, yeah, I just flipped it. So let's go ahead and back. I'm going to lift it up a little bit here just to make sure that we're not. Okay, let's see what's on the other side. Wow. That switch isn't working. Oh, man. All right. Pull the board back out and see what's up with that switch. I don't have a replacement, but a lot of times you can just take those apart and give it a bit of a cleaning, and it should be fine. So let's go ahead and do that. Okay, let's go ahead and pop this switch out, and it just has these tabs on the sides that kind of hold it into the plastic there. So there is the switch, and the way these come apart, let's go ahead and zoom in, stick something in there, and then just pry up on the rocker. That's that side. Makes the other side a little tighter, so I'll have to get a thinner flathead here. Yeah, I mean, I have some switches like this, but I don't have any with like terminals that are super long just like that. So let's see if we can actually clean this one up and get it working again. See what that looks like. So under magnification there, I mean, it looks a little crusty, but not too bad. This is the center that would be making contact in there. Let's see if we can get that a little better. It's in there, so that, I mean, that looks okay. So what could the issue have been? Oh, that terminal there looks pretty freaking burnt. Maybe what I'll do is I'll scrape that a bit. Yeah, it's got so much crust on there that it's probably just not making contact at all anymore when it hits that side. So if I can keep this here in focus, let me see if I can get something to scrape that with. All right, so, oh wow. Yeah, that is just like a nice crusty layer that was on there. It's probably, it could have just been like burnt on lubrication because there was like a little bit of grease and stuff in here. And it tricked us because I didn't even think about checking the switch. Okay, so that should be pretty good metal there for the contact to touch there. I'm also going to clean this off a little bit, even though this side doesn't really appear to be the problem, but we're just going to get some of that grease off of there. I will scrape it just a tiny bit just to make sure we get like that stuff off right there. We're also going to clean the center part here a little bit because that's where it pivots on the other contact point, and for some reason this is a little blown here. Let's get down a bit. I guess that's okay. All right, scrape that off. Yep, that's more crustiness right there. Check that out. And that contact in there, let's see how that looks. There it goes. It looks like it's pretty shiny, so maybe that's not necessarily part of the problem, but we're going to scrape that just a little bit as well. Crust is good on pizza and like some breads, but not really for contacts. You know, it kind of sucks for that. All right, so this is what I'm going to be using here. This is just this super lube stuff, and it's what I have on hand, and I think it should work fine for this. So let's go ahead and get just a little bit of this out, and I'm going to put some on that contact and on the center there. I mean, it's just like a tiny or really thin coating. I'm not laying it on like super heavy or anything like that. It's just to protect those terminals from corrosion. And it's also, just put a tiny bit here, and a tiny bit there. I'm gonna line it just like that. There we go. Okay, so now to put the rocker back on, because it can technically kind of like go on in either direction. We want it to go on in the proper direction here, so got to get that ball back in that hole. It's spring loaded. Okay, so there's that. Okay, so basically the line goes on the opposite side of where you want contact. So when you rock it this direction, it pushes that pivoting arm there to make contact between the middle and the opposite side. So it goes like that. So that's the direction that I'm going to put this in. So I'm just going to carefully try to snap it back into place there. And okay, so that feels like the ball there is in the proper location. So that should work. Let's check continuity now. So when it's here, the switch should be off. So I should not be getting any continuity at all. Nothing. Okay. I'm going to switch to on. Now I should be getting like full continuity across. And there we go. That is perfect. Okay. So now let's go ahead and put this back on. And which direction did it go in? Let's see. It went like, yeah, it went like that. So pop that in. And pop this back in. Sure, we got plenty of solder there making good contact. And on this one as well. Okay, that should be good. We're going to do negative, and I don't have the power supply on yet, so it shouldn't do anything, obviously. All right, hitting the power supply switch, so power supply is not on. I mean, now on. Here we go. 3, 2, 1. It takes a second. There it goes. All right, so it looks like the primary issue was actually the power switch, and this is like drowning everything out. Let's see if can we put this on maybe a little better. Oops, I hit the power switch there. I mean but it is working, and that's what we wanted. So man, that switch really, it got me there. I totally thought maybe it was going to be something more like active electronic that was bad, but nope. And I have a feeling it probably would have worked even with that kind of crusty looking, I'm not even going to touch it, but that crusty looking connector there. But I mean, it's good that we fixed that as well, so that way we know we're not going to have any issues anytime soon. But yep, it's working. So, well, that was technically an easy fix, even though I started going down like the rabbit hole of checking things that were not the problem. But glad that worked out. Cool. Thank you guys for watching once again. If you stuck this to the end, yeah, thanks guys once again. I'll see you guys around the bench.